Alright, so this is coming from chapter 2, and we're going to talk about modeling. So what is modeling? Well, modeling is taking um, a real-world problem and it's describing that real-world problem, taking it from like the English language and putting it into mathematical terms, um, forming equations. So we're kind of like translating from English to math. So let's take a look at this problem. And let's read through it. It says a car dealership advertises all 15% discount on all its new cars. In addition, the manufacturer, correct the spelling there, offers a $1,000 rebate on the purchase of a new car. Let X represent the sticker price of the car. And so we start with part A. Is suppose that only the 15% discount applies. Find a function f that models the purchase price of the car as a function of the sticker price X. So if the sticker price is, they tell you in the problem that the sticker price is X, and it says here only the 15% discount applies. So when you're talking about a percentage off, you're talking about if you take 0.15, 15% written in decimal form, means that you drop the percent sign and you move the decimal 2 places to the left. So I write 0.15. If you take 15% and times it by the sticker price of the car, that's going to give you the amount that you take off. It's the amount of the discount. This says to find a function f that models the purchase price of the car. So this gives you the amount of the discount, and then you would have to subtract it from the purchase price of the car. But we could write this a little different. So think about it like this. When you're talking in terms of percentages, percentages mean 100. If you are adding a percentage, it would be 100 plus p. Or if you're talking about something that would be more than, it would be 100 plus p. But if you're talking about something that would be less than the price, then you would use 100 minus p. So in this case here, the function that models the purchase price of the car, if there's a discount, then the purchase price is going to be less than. So I would use this, and I would say, okay, well, it's 100 minus 15%. So that would give me 85%. So if I take 85%, write it as a decimal, and I multiply it by the price of the car, the sticker price, this will give me the new price or the purchase price. So you're paying for 85% of the sticker price. So writing that in a function form with x as your input would look like this. It told us to use f for the function name, and the sticker price is x. So I'm going to say 0.85 times x. So this would be the model for that description in part A. Now in part B, it says suppose that only the $1,000 rebate applies. We'll find a function g that models the purchase price of the car as a function of the sticker price x. So if it's only $1,000 rebate, then the purchase price of the car, or the new price, would mean I would take the sticker price and I would subtract $1,000. So there's no percentage off. It's just an amount off. So putting in, they tell us to call this function g. So g of x, the sticker price is x, will be x minus 1,000. So now I've created a model for that scenario in part B. Now in part C, it says find the formula for H, where H is F composite G. So this little circle here means the composite function, and it means that we take F of G of X. So the F of X, let's color code this. F of X was equal to 0.85x, and G of X was equal to x minus 1,000. So if I am writing F of G of X, or F composite G of X, F composite G, I'm going to substitute this part in place for the input. So I'm going to say this is equal to F, where my input is 100 minus, I'm sorry, X minus 1,000. And so I'm going to plug this X minus 1,000 into my function F. So in place of X, I'm going to put X minus 1,000. And now I am going to distribute the 0.85 to this term and to this term. And I'm going to get 0.85x, and then 0.85 times 1,000 would be minus 850. So that would be the formula for the composite function. And that would be, we called it H. Now continuing on, in part D, it says find the inverse of H. So this is the inverse notation. And so to find the inverse of H, what we're going to do, when we try to find the inverse, what we do is we're going to take and we're going to write the function, but swap the variables. So the input and output variables. So I'm going to swap normally I would say x and y, but in this case it would be h and x. So swapping the variables. And then now solve for that variable that you swapped. So what do I have to do here to solve for capital H? I am going to add 850 to both sides. And I'm going to end up with x plus 850 is equal to 0.85h. And now I will divide everything by 0.85. And in doing that, I'll be solved now for h. So I'll have x over 0.85. And I'm going to put this in the calculator. Remember, there's a 1 here. So 1 divided by 0.85 will give me a decimal, and I'm going to just round that. And then I have 850 divided by 0.85, and I'll put that in the calculator also, is equal to h. And so if I round that 1 divided by 0.85, I put it in the calculator, I get 1.176, rounding it to 3 decimal places. 850 divided by 0.85 works out to be 1,000, is equal to h. And then I'm just going to swap the sides so that and write the notation for the inverse function. So this is the inverse of h. And so this would give you the original sticker price for the given discounted price if you use this function. And so if we find h, the inverse of h at 13,000, saying that this is your discounted price, it will produce the inverse. It will produce the original price. So let's plug that in and see what we get. So in place of h, I'm going to plug in 13,000, and putting this in the calculator, 1.176 times 13,000, and then add 1,000, it will give me 16,288, which would be the original sticker price. So we took the composite function, meaning both discounts, and then we found the inverse. The inverse gave us the ability to substitute in or plug in the discount for the input. So plug in the discount for X and you will obtain the original sticker. And if you paid $13,000 for a car, the original sticker price would be $16,288 if that was the discounted price, the $1,000 rebate, and then the 15% off.